Hello, welcome to another video. Today I'm looking at the sound source type 4224 from Brüel and Kjær, and this unit no longer works. So the goal of the video is to go through, do a little analysis of it, just kind of a general overview, make sure all the parts and pieces are there, and first thing we're going to do is do a visual inspection of the inside and see if we can find what's wrong with it, and then hopefully be able to get it working again. So you can see the thing comes apart pretty easily. There's a bunch of screws basically holding it all together. It's got some kind of unique features, you know, big old speaker in there, and then it's got these little fiberglass panels here. There's just a little bit of absorption inside the box just to help tune things. And it's got obviously the big old speaker, some wires, and then we have some batteries on the bottom, which haven't worked in many, many, many years, but they are still there. And there it is, all the good stuff. You can see this thing's pretty chock full of electronics, kind of surprising for basically just an amplifier and a noise generator. Here we can see a close-up shot of the diode that's gone bad. You can see the other side of the circuit board is actually burned right through the board. So we actually have a place to start to look for things wrong inside of here. So, yep, we have a burned out diode and we need to figure out why. So the first thing I'm going to do is go through the whole board and just check for shorts or issues with any of the circuitry and basically just try and find if there's anything gone seriously wrong. So the first thing I'm doing here is checking these transistors, the main power transistors, to see if they're shorted out or if there's anything wrong with them, and they look like they're fine. So this troubleshooting process will go on. We can't do a voltage check on this thing because right now when you try and turn it on, smoke comes out. So obviously there's something gone further wrong than that. So we can't do that. So we go through, piece by piece, just check components and make sure things aren't broken. And the next process after this is we're going to take that diode out and install a new diode and basically bring the voltage up slowly and see what happens. So I have the user manual for this instrument, and I have all the different pages, and it goes through, and it's pretty vague. It doesn't give you anything like a schematic or anything like that. It has a block diagram, but it really doesn't tell you enough about the inside of this to tell you how it's actually operating. So this thing has a mains transformer, which actually drops the voltage down to 12 volts. It has a 12-volt input, but then it also has a step-up switching power supply, which gives you a whole bunch of different voltage rails. And so you get a plus and minus 47, plus or minus 42, plus or minus 15. And all those different voltage rails are used together to create the different systems that are needed within the noise generator and amplifier circuits. So there's also a 5-volt rail. So let's replace that cooked diode with a nice new Schottky diode. And then we're going to go ahead and hook it up. So we have a resistor for load and a little speaker there just to monitor what's coming out, and a multimeter to monitor the voltage. And so we're going to apply some AC voltage and just slowly bring that AC voltage up and see what happens. And hopefully nothing bad happens. So 20 volts, things are looking okay. No smoke coming out. 30 volts, still looking okay. Yeah, it hasn't actually powered up yet. So we're going to bring it up a little more. We have to do this nice and slow because we want to see where the fault actually lies within the system. So I have a thermal camera. This is another tool that you can use to see if there's heat coming out of any part of the circuit. So to see if there's like a blown up chip or something like that, it'll show up as a hot spot on the board. So far, not seeing any problems. We'll take it up another step, still not seeing anything. And then finally we get it. It tries to start. So it's using a lot more power now. You can see it's using almost an amp of current. So it's trying to start up and still not working though. But you can hear that noise. It actually makes a little bit of high frequency noise as it's trying to run. It's a little bit on the annoying side, but it, this is normally enclosed in a case, and honestly, the amount of noise that it makes when it's operating correctly is far, far more. So we're going to take it up to max voltage, and there it is. Smoke. The magic smoke has escaped, so it definitely does not work. And we can see that diode actually burned right out again. So I've gone through, there's these little jumpers inside on the board that you can just remove. So I've gone through and I'm actually injecting the 15-volt rail, which seems to be where the problem is. That's what that diode is actually feeding. So I'm injecting 15 volts separately now, and we can actually see that it's actually operating. So with the 15-volt rail being supplied, we can see that all the other circuitry inside the unit has started to work. So by externally supplying that rail, we can actually get the whole entire system to come back to life. So we know that the rest of the circuitry is working, and we know that the switching power supply isn't able to supply the plus 15 volt rail. So we need to find some components within that pathway. So the switching power supply is supplying all of the other rails, and this is all coming off of the same transformer. So we know that the switching power supply is working correctly, but that the 15 volt rail is not supplying the current that it needs to. So we can play with the voltage coming in. You know, it's got a range that it's supposed to work over. So overall, the system seems to work really good. When we take the voltage a little too low, it does go into an under voltage lockout condition, which is a safe operation. If you go too high, I didn't test that, but I'm sure it's got some kind of protection on that end too. This is made to run off of the battery, like I said, and it also has a DC input on the back, so you can run this from like a car battery, for example. The input on the transformer also has many taps, so you can also run this from many different AC voltages. It's basically got a variac built in. So that 15 volt supply is what's making it work. And so we finally figured it out. We went through, and there's this tap right here, and before that tap, there's the diode and these capacitors. So those two capacitors have to be the problem. So one of those capacitors has to have failed somehow. And here it is, and I pulled it off the board and given it a little bit of testing, and it's a Siemens brand, and it's a 2200 microfarad 16 volt capacitor, and it just 0 ohms. Come on, that's not supposed to be what a capacitor is. So yeah, that's the failure point. That capacitor's failed short. So now we're going to replace it with a Nichicon 470 microfarad 63 volt capacitor. And you can see that the multimeter's counting up, climbing ohms. That's a good sign. We know this capacitor's good. It's new. So the current that these rails were supplying was only on the tens of 20 milliamp range. So they don't really need that giant capacitor. There was no reason for that. So replacing it with a 470 microfarad capacitor is plenty for the amount of current and the way this circuit is being used. So with that new piece installed there, running it with the DC power supply and going through the modes and just testing things out, it's working fine. So it runs off of the DC power supply. There's no issues at all, and it's all just put back together. It's got to replace that diode again with that new capacitor. Yeah, seems to be working great. So the failure point on this unit was a diode, but the actual failure point that you couldn't see was a capacitor. And the diode just had less thermal mass, so when the capacitor failed, it didn't blow up. But instead, the diode, which doesn't have much thermal mass, was the thing that was in overload condition because it was trying to drive that dead short capacitor. It's the thing that went pop. All right, so here it is powered off of the mains, and we can go through and do the same exact thing as we did with the DC power supply and run it same way. Just going and checking it at the various modes that it has, turning the volume up and down, just checking the different attenuation settings and everything, and you can see that, yeah, it's a winner. This thing's all working again, so great. So these little test points are really cool. I know it's hard to see it here in this video because it's a really tiny little thing, but these little things just pop out and you can open and close them. So now we're going to do a little bit of reassembly. I cut out a lot of the disassembly part of the video just because it was kind of boring. But we'll go through and show you some of the reassembly process. Mostly it's just putting lots of tiny little screws back in place, and they have these little brackets that kind of hold the whole chassis together. So in summary, this is an older piece of equipment, but so yeah, this unit dates from the early 90s, and from having essentially no maintenance from then to now, and its basic job is to make a lot of noise. So basically just blast all the time. It's done pretty well. All right, so here it is, all back assembled and ready for some basic testing. You can see it's got its little power cable plugged in. We're set to the AC voltage. Let's go ahead and turn it on. I'm going to set the attenuation down, turn it on. See the red light comes on, so that means it's working. And there it is, noise. So the type of noise this thing makes is called pink noise. And this is really useful because it offers equal power in each 1/3 octave band. The equal power in each 1/3 octave band is useful for things like building acoustics measurements, where we want to measure how much sound transmits through a wall, or for measuring things like reverberation time in spaces. So this all-in-one device, which also has an external input, was very, very useful for a lot of building acoustics and things like that, where it just, had a known signal that it made, and it was able to basically turn on and off that loud noise source all in one compact package. So that's it. Thanks for watching. Stay tuned for another video.